So thank you for joining me in this small, hot room that does not represent Norwegian weather at all. The plan is to talk about what works and what doesn't work in unit testing, and basically take a look at source code from several open source projects. And in the meanwhile, talk about three pillars that make unit testing work, or at least in my experience, have been making unit testing work in a lot of places. It's based on a book called The Art of Unit Testing, which I'm currently writing a second edition of. And if you're interested in learning more, you can just go to artofunittesting.com. You can also just contact me directly, since I just started working at a company called Bouvet. And the plan is to do consulting and training through Bouvet all over Norway. So I'm happy to get your contact details and spam you. Okay, so the agenda. We're going to talk about what it means to be able to trust your tests. Why is that important? Obviously, we think that we do, but usually we don't. We'll talk about maintainability. Obviously, most of you understand that maintainability of unit tests is important. And we'll talk about readability. A lot of us don't really care about readability until we have to read someone else's unit tests. That is why most of us try not to read anyone else's unit tests ever. What we'll try to do today is to read someone else's unit tests and try to figure out if we can understand them and what makes them more readable and understandable. So first of all, what does it mean to trust your tests? How do I know that you are able to trust your tests? It is about human behavior. If I trust my tests, there are some things that I will not feel that I'm compelled to do. For example, if you run your tests and then you just get into the debugger just to make sure, then you don't trust your tests. Okay? Now, what's the point of running the test if you are not saving the time of the debugging? A lot of the ideas behind test-driven development are to save all the time that you spent on debugging by automating things, and then you can focus on more interesting and important things. So if you still do debugging, after running the test and they pass, something is wrong. We'll talk about how to fix that as well. And if there's one thing that I want you to take away from this talk today, is that if you want to make unit testing actually succeed in your organization, you have to learn to do a new practice. Not code review, but test review. A lot of you may have already been doing code reviews, but what I'm talking about is a test review that not only checks the source code, but also checks the tests. And it's not done in an automated manner. It's done with you sitting side by side with the person who actually wrote the code. Unit testing is about communicating intent. And when you are reviewing someone else's tests for readability, maintainability, and trust, what you want is to teach them how to be better at unit testing. And if you're doing it through a tool 5,000 miles away, it's going to be much less effective than if you're sitting right there, side by side. And you can see the expression on their faces when you ask them, will this pass or not if I run this? If I remove this line, will this test now fail or not? And you can see exactly how they react. You can understand what they went through when they wrote the code. And they can understand what you mean more because they can see your hand gestures, they can hear your voice, they can smell your sweat as you get excited or annoyed about something they wrote. Everything is important. Communication is the key here. And what we're going to do is to communicate as much as possible through tests. Now, if you do test reviews, you will also get an interesting benefit. And that is that your code reviews might actually be faster because you will find problems in an easier manner, in a faster manner. Because unit tests are supposed to communicate intent, sometimes you just need to look at the name of the test to understand that the programmer got the whole requirement wrong. Instead of looking at a class 500 lines long, already bad, by the way, and 300 lines into it, you will say, aha, so only after this you actually delete the customer. No, you got the whole thing wrong. But if the test name says it, then you can actually save all that time. So understanding what they were trying to do. Test reviews are inputs or entry points into the code because they are really small use cases. So if you want to debug a use case, you can go and actually start a unit test, hopefully. That should be the point as well. So if your team is learning how to do unit testing and you're not doing test reviews, you're not actually reviewing the code, every line of code that was checked in for a few weeks and sitting there with them on the tests, you are much less effective than you could be. You might actually be doing harm because for a few weeks they will just be writing tests how they think they should in their own little bubble, and they're going in several bad directions. And after a month, it's already too late. They have habits. You don't want to have the bad habits to start early. You want the good ones. Also important, the 3 pillars of unit testing collide with each other. If one of them fails, the others fail. If you cannot read your tests and they start failing, it's hard to maintain them. It's hard to understand why they're failing at all. If you don't trust your tests, it doesn't even matter if they're failing. Has anyone ever had this happen? You run all the tests, some of them fail, and you ask the people on the team, this is failing, what do you think? And someone says, don't worry, no problem. It's okay that it fails. Just continue on. Don't worry. It's just a configuration issue. So now you have a bunch of tests, some of them failing, and you don't trust them anymore, even if they're failing. So what was the point of running them anyway? And maybe they'll tell you, you know what, just make this configuration if you really want this test to pass. And then what are you going to do? You're going to say, I don't have time to do this configuration. I have better things to do, like actually code new features or fix an existing bug. So I'll just assume that if I was to change that configuration, the test would pass and everything's great. And then you move on with your life. And of course, maybe that has been failing for 6 months and everyone has been telling themselves that. And so the trust in the test is very, very important. It doesn't matter if they fail if you don't trust them. Okay, so to be able to trust your tests, there aren't many good ways to do it. How do you know that your test is supposed to fail when it should and supposed to pass when it should? When you do test-driven development, that's one of the only ways I know where you're actually testing the test. Because in TDD, what do? You start with a failing test, and then you make it pass by changing production code. In that feature alone, that practice alone, you are actually making sure that the test fails when it should and pass when it should. If you are just testing after the fact, your test should just pass. But you never know if it fails when it should. So there is little trust. That's why you feel the need to debug. And that's why sometimes if you realize you actually had a bug in the test and you go and fix the test, now is the time to go and comment out the production code line to see the test fail again so that you trust it again. Whenever you fix tests, repeat the bug that they're trying to solve to see that they still fail when that bug happens so that you can trust them. Another important thing is to separate unit tests from integration tests. Now this is an example from a .NET solution, I know. But a tree is just a tree. It doesn't really matter what language it is. If it's separated into integration tests and unit tests, it is, or it isn't. It doesn't really matter what the language is. And what I would recommend is if you want to trust your tests, if you don't want that thing where someone says, don't worry about it, if you don't want that to happen, you should have at least one project or all projects that have unit tests to be separated from all things that are not unit tests. So let's define a little bit what a unit test and integration test is in my point of view. A unit test is fast, it runs in memory, it is repeatable, it is consistent, that means it always returns the same result when you run it. For example, if you have a random number, it doesn't always return the same result. It is always the same test, so it doesn't use dates that keep changing. It doesn't touch the file system, it doesn't touch databases, so it's fast. Anything else, and one last thing, the test has full control of everything of the unit that it's testing. Everything else is an integration test. So if your test is touching a database or a file system, or it's using threads or random numbers or locales, then it's integration test in my opinion. And the reason is that there is something inside your test that you do not have full control of, that you have to wait for, that you cannot really control. Threads is something you have to wait for. So the test will run not only slowly, but sometimes run X amount of time, sometimes Y amount of time. So for each project that I'm testing, I will usually have 2 test projects. One is integration test, and the other is unit tests. And here's the nice thing. With unit tests, because they all run in memory, they're fully repeatable, you should not have these configuration problems where some of them fail sometimes, or they fail every 3rd day, only if the moon is out. You don't need that. That's an integration test because it relies on something external. You need to have this, I call it the safe green zone. A safe green zone is a project you can check out from the source control, get the latest version, right-click, run all the tests, and they should all be green, no exceptions on that project. And if even one of them is red, you should truly be worried because someone checked in code that actually fails a test. Okay? So you should have a safe green zone where tests should not be failing. And all the other tests are integration tests, so you can expect them to fail sometimes. But at least you have separated what you should trust and what you should trust less. And then at least you have this kind of safe feeling that you have something that you know should run actually runs. You don't have to debug those things if they pass or fail. You just know if they work or not. By the way, I said that the test is testing the unit. It has full control of the unit. What is a unit in a unit test? I used to feel that a unit is the smallest piece of code. It's just a method. But then I realized that some methods are private, and I don't like to test private methods because private methods are usually part of a bigger theme, a bigger action. Private methods don't exist in isolation. If a private method is there and no one calls it, does it really matter? If it crashes and no one hears it, does it really make a sound, etc.? If a private method never gets called, you can delete it. So, if every private method gets called by some other method, which eventually gets called by some other method, which somewhere there is a public method, an entry point, the start of an action, of a use case in the system, that triggers that chain of events. That is our unit. That is the entry point of the unit. It's somewhere public, because that's where we usually start. So the entry point of the unit is usually public, or at least internal, for security reasons, but it's not private. And then, where does it end? Well, a unit, as far as I've seen, only has 3 types of results. It either returns a value back to the caller, so it's not a void method, it just returns something, or it throws an exception. Or that's one, that's a return value. The second type is that it changes the state of the system so that the system behaves in a noticeable way differently. So from your own API that you invoked, you can actually see that another API may be returning a different result now. If you add a user, and there is no end result to be returned, but now you can actually log in with that user, the system behavior has now changed in a noticeable way. Before you couldn't log in, and now you can. So the behavior is different. That's the second. That's state-based testing. And then the third type is when you call something you cannot control. For example, you have to write things to a log file. Nothing is saved in the system, just the log file is being called. And we don't want our test to be an integration test, so we fake the log file. We create a mock object of the log file to make sure that the logger was called. And if the logger was called, we assume that this third-party thing we cannot control was called, and everything's good. That's the third type, calling a third party. That's the only place where we would use mock objects. In all our tests, we probably would have fakes, or things that we use to stub out various behaviors. But we would never assert against them. Because if we were to assert against them, that they were called, then we're actually checking that and the end result is calling somewhere. And in our tests, we should strive to test only one logical concept. One logical concept means that if a unit can have multiple end results, each end result is its own test. So if a unit both returns true or false and saves to the logger, that's two different tests that I should be expecting. This is important. The reason I want to separate them is because if one of them fails and they're both in the same test, the other one never executes. So I have less information about what's going on. And we'll see some of these tests. So in terms of trust and readability and maintainability, testing publics is usually a much better way to go in testing one thing. Here's an example of a test. This is, if I'm not mistaken, either from Xstream or JBehave. I'm pretty sure it's from Xstream. You can see that, right? No. What you can see is basically, I'll tell you the name of the test. It's very easy to understand. Assert that all number types are accepted. Okay? Assert that all number types are accepted. It takes a parameter of some object, and then it has about 20 asserts. Now, test might actually be kind of readable, but there is a maintainability problem and maybe even a trust problem. What happens when the third assert fails? All the other asserts never get executed. And then in the book XUnit Test Patterns, Gerard Mesoros called it, I think it's called assert roulette, where you basically, what you do is you fix the thing and then you run it again and you wish that everything else would just pass, but you don't know. And I kind of agree with that, because what you can end up with is that you're like a doctor who's seeing a patient. And the patient only tells you half the symptoms. And you still have to fix the problem. So the first assert that fails actually hides all the other assert results, because it throws an exception. Maybe if I knew that out of these 20, 3 of them fail and the rest are passing, I would look for the problem in a different place, maybe a deeper place or a less deep place. But because I have to go through one by one, now I have to fix that, see what happened. Fix that, see what happened. Or you end up with commenting out various pieces of the test just to see how the other asserts behave. That's a perfect symptom of a case where you probably want to separate this into multiple tests, because each one of these tests is a feature that you care about. Okay? You care about being able to work with longs and floats and big integers, and regardless if the other ones are working, if big integers should work, being parsed, regardless of whether long can get parsed or not. You need to know if that feature works. Another thing that sometimes I see in tests is that test code gets reused or doesn't get reused, and so it becomes very hard to read and very hard to maintain. So I like to have factory methods, and I actually name them make underscore something. And the reason I use underscores in my tests, because it's easy for me to understand that these are test-related helpers. They're not just logic-related, or they're just not utilities, but they're specifically for the current class. So I will have factory methods to make a specific object if I keep creating the same object in multiple tests. But why would I even have a factory method to create an object in a test? One reason to have a factory method is so that if your constructor changes tomorrow, you don't have to go and change 100 tests to make everything work again. Now, one way people solve that is by having a setup method. Who here has ever used a setup method? Okay, I generally don't recommend that you use setup methods. The reason you should probably not use setup methods is because it hurts readability very much. You read a test and you try to understand where an object came from, and now you have to understand the test in 2 places. Sometimes you have a setup and a teardown to understand why things are happening. So the more you divide the test so that the user understands less just by reading the same method, the harder it is to read. So instead of using setup, I just use factory methods, and I call them from each test. The maintainability is still there, but the readability also is unaffected. Okay? And for very special cases, I will also have special asserts or verification. I call them verify something. Those are helper methods that have asserts inside of them that I can call with multiple parameters. Some frameworks already allow to parameterize your current test, JUnit theories, etc. But not all frameworks have this, and in that case, I would have this naming convention called verify. This is also important for readability, because I look for that, and it's very easy for me to then look, even in IntelliSense, to look at all the verification methods. Okay, so here's an example of a test that has several problems. Now, I know that some of you can't actually read this, but those of you who are close, I'm going to attempt to quiz you. If you see any specific problems that you would like to change in this test. Does anyone see the test name and can read it, by the way? Who's close enough? People in the blue shirts. Blue Men Group. Can you read the name of this test? Can you read it loudly? Yeah. Should map stories by filter in lanes. Okay? Now, whenever you see a generic name like that, should map stories by filter in lanes. And then, I don't know if you can see that, but just below here, you see a lot of asserts, a lot of things going on here. This is again a case of probably you should separate this into several tests, but not always. Because sometimes I don't have a problem with multiple asserts in the same test. Because if they're on the same object, then they're basically testing one big logical thing. For example, you get a person object with a name and an age. You can assert on the name and an age, and if one of them doesn't work, you really don't care about the other. So the question you should ask yourself, is it okay if I use multiple asserts here? And if you ask yourself it this way, if this one fails, do I care about the others? Nah, then it's okay. If you say, if this one fails, I still care about what this one says, then you should separate it into a separate test. It's all about how you feel about the test. But there are several good things that you can see here. I don't know if you can see, but you can see the spaces, right? You have spaces to understand range, act, and assert places. And I like separating, much like a story, we have beginning, a middle, and an end. But there's something interesting going on here. Here, we actually have a loop. And I'm not a big fan of having logic in your unit tests. And the reason is that if you have logic in unit tests, and a logic is anything that is, as far as I'm concerned, kind of flow control. So loops, switch cases, ifs, is that you can actually have a bug in what you loop against. You can actually have a bug if you have an if. If you have an if, you're probably testing multiple things anyway. So how long do you expect these tests to last in your project? You're writing tests that will probably last 5, 10 years. Over a 5, 10-year period, the possibility of this actually having a bug becomes actually very real. You don't want to take that chance. So tests should be as simple as possible and as stupid as possible. They should just be statements. Do this, do this, do this, assert that. If you have to have a loop, maybe you're testing with too many things. Maybe you can actually simplify the test and say, do I really need to use an array with 30 things when an array with a single object will prove my point just the same? And some people will say about that, but then how do I know it really does work? And I would say that if you prove the simple cases and you prove the complex cases in a simple way, you prove the basic edge cases. And test-driven development is not about proving that everything works. It's about driving development. It's about creating source code in a maintainable way, in a way that is actually possible to achieve in a speedy way, because you trust things and you can change them. But it's not about filling all the gaps of all the things you never thought about. It is about creating a structure, a spine for your program of all the good things that are working. That's why when I work in TDD, I usually ask people not to start with all the problems that could happen. If you create a parser, don't start by writing tests for all the bad things the parser can accept. Because you get to the end of the day, your manager asks you, so what do you have working? And you're going to say nothing, but it handles bad inputs perfectly. That's not what you want. What you want is to have predictable output, that you always have something more than you had before. After you have this spine of working functionality, then you can actually go and add all the other things, all the edge cases, all the small things. And I would put them in a separate project or in a separate class called advanced experiments or advanced tests, or usually something with the word experiment, because these will usually be less readable. These are the tests where you might have flow things, like do this, assert that, now do this and assert that, and do this and assert the other thing, and create really complex inputs. And those are the tests that you do to make you feel even just a bit more safe about the code that you just wrote. There's nothing wrong with them, just don't call them unit tests. And don't do them at the beginning. Do them after you have something actually working. So usually when I see loops, it tells me that maybe someone is trying to write a test that is too complicated than it actually needs to be. Or that this test should be in a separate project called experiments. This is an example of a test that ends up as an integration test. Now, I don't have a problem with this test as a test. I have a problem with the location of this test. Because this test in the extreme project, or Xstream project, resides with the unit test folder. It's actually inside the unit test class beside other unit tests. So it's a prime candidate for one of those tests that passes every third time, or it passes only a really fast machine or a really slow machine, or something like that. So I don't have a big problem with it, but I would definitely move it to a project called integration tests. And you can see, if you need loops to kill threads at the end, it's not a bad thing, but you're definitely doing an integration tests if you don't know how many you have. This is an example of a unit test, but the test keeps changing. Every time you run the test, it's a different test, because it uses a new date every time. Now, the test itself doesn't care what the date is, it just cares that you can translate it from one thing to the other. But if I was to rewrite this test, I would use a hard-coded date in my test, so that every time it runs, it is consistently using the same date. Because at some point, maybe, it will start failing with a date, and then it will stop failing with the same date. And it's really hard to actually expect. Imagine that this test is actually failing. And so you see asserts of things that are supposed to happen. So you assert that the in and the out are the same. Okay? Now, the in and the out are based on the same object. Okay? They're based on the same object, but something is wrong with the formatting of the date. So it has nothing to do with things being equal to one another. And so your test will fail with a different exception at all. It's going to be hard to find what the input was at the first place. And maybe for some dates it's easy to recreate. Maybe sometimes it's milliseconds that would have changed the result. And now the opportunity to recreate this problem is gone. So instead, what I would do is use a hard-coded date here and then have a separate integration tests that will use millions of possible input rows of dates to test multiple date formats and all that stuff. If anyone needs water, I have some right here. Just raise your hand. I'll throw it at you, but you cannot sue me if it hits you. Anyone? You see, I'm being agile. There you go. Be careful. Yeah. Then I'll take off my shirt, and someone can get it. Okay. So what's wrong with this test? Come on, something's wrong with this test. So imagine you're a serial killer, and you know where the person who wrote this lives. And you look at this test. Is there anything you want to ask that person? Come on, I know you want to ask something. Yes? Why? Why what?
Why? I mean, why write it?
Why write it? Okay. That's a very vague question. That's a good question, although I had a more specific one in mind. Something, let's assume that the test is okay in terms of why you would want to test it, because we don't care about the domain of the test. We just care about the way it's written. Yes? If it fails, you don't know if? Aha. If it fails, you don't know which one of the calls was failing. The make date or the get year. That's one. That's good. So separating the actions from the asserts. What else? Yes?
Too high exception. Like you catch any exception.
The exception is too generic. Interesting. I didn't think about that because I come from the .NET world. Throwing exceptions. Well, I'm pretty sure that the test framework will catch the right exception anyway. It might fail for the wrong exception. I don't know. Maybe. Anything else that bothers you? Yes.
The date and month.
The date and month. What's the problem?
Well, which is date and which is month?
Which is the date and which is the month? That's good. Anything else? Come on, it's just one line of code and you only found 4 problems. Sorry?
Duplicated code.
Duplicated code.
2004.
2004 is duplicated. Huh. Interesting. Okay. Okay. I actually don't have a problem with this code duplication. I believe that it actually makes things more readable. You were actually raising your hand first. You wouldn't use the word test in the method name, but sometimes the test framework requires you to use the word test. Okay? Nice try. Yes. January 01. What? What's the question? You just threw something at me.
When you make the date,
Yeah?
if you want January,
Yeah?
a 0 or a 1.
Mm-hmm. So you think there's a bug there? So what's the problem? Make yourself clear, people. You have to learn how to explain to people what you don't like about their test in a very nice way. Should I really tell you? I know you're getting annoyed, but I really want someone to win a book. Oh, now it's interesting. Yes?
Do you have a dependency on date you code or static? You might want to be able to replace it.
I have a dependency on the static date. No, that's not it. It's no dependency because date is a built-in. It's not something that you might usually have to fake. It's just a value object. Yes?
I wouldn't have had it on one line. Use variables to sort it out so you know what you're putting in.
Use variables to sort it out. Definitely separate things from variables. But you know what? Here's what... Really? Okay, one more, but then that's it. Because we still have like 100 hours to go. Yes? Test name is misleading. Okay, now we're interesting. Test. Get year. What's the problem with this name? It's very short. Is that good for a test name? Yeah, you do more than get year. So the test name, I agree that it's misleading. There is a readability problem. Usually in test names, I look for 3 things. The thing you're testing, that is, what is the unit? The scenario, for example, given a date that looks like something, or a date in the past or a date in the future, and the expected behavior. What is it that I'm going to check? Because if this test fails out of thousands of tests, I'm not going to have the comments on the test. The only thing I'm going to see in the runner is the name of the test. And if the test name is good enough, I won't even have to look at the code of the test. I can just go to production code by just looking at the name of the test. So in this case, asserting that make date, that's the thing we're actually testing. Given a specific year, you can actually get the year from that, or something like that, I guess. But there is something else, just a little thing that bothers me. It starts with the word why. Why 2004? Why 6 and why 1? Why are these dates important? Are they important? Are they not important? If I write a test in this project, should I use these dates as well? What's so special about these dates that you wanted to use those specific dates? And that's an important question. Because what this question leads to is a bunch of repetition. If you don't know why someone is doing something and you're writing tests in that same project, what you're going to get is 100 other tests with the same date. And then you get 100 tests with all using 2004, 1, and 6. And they're all just, and nobody knows why. It just started 10 years ago when someone used 2004, and that moment it moved on. And I don't want the reader of the test to have any reason to ask me a question. I was talking about testing public, so I'm not going to repeat that too much. Okay, so this is another example of a test. Well, the name is kind of okay. Test unmarshal old extreme dates that lack millisecond. Okay, so that's, we have the scenario. We don't have the expected behavior in the name, but we also have another problem here. The problem here is that if one of them fails, we never know about the others. And each one of them is a separate scenario. Each one of them is a different requirement. It should work if you have this space. It should work if you have that space. It should work if you have, look, it even has a comment at the end. It says, need correct local time, no TZ info in string. No time zone info in string. Okay, so that's really a special scenario. The name of the test doesn't say that. And you know what? I'm pretty sure in the production code, there is a big bunch of logic that, that handles each and every one of these distinctly. And that's an important thing. Because if one of them fails, you still want to know that all the others are actually passing. So you want to be able to support the requirements, and the test should be readable enough to understand each requirement separately. You want your tests to be maintainable, they have to be isolated. Every test should run in its own little universe. It should have data that doesn't depend on anyone else, and it should release the data or reset it at when the test finishes. For example, never have tests that call other tests. If you've ever seen that, that's usually a way to try to save coding, because a test is doing a lot of work, so you call that other test, and that other test is doing a lot of work too. So you're kind of refactoring in a way by just having that other test do some of the work. But instead, refactor the work into a helper method and call it from 2 tests. Because otherwise, you remove one and the other one breaks. Or you change the order because you move in the line order and one of them breaks. So tests should be able to run in any order, and any part of the test should always pass, because they should not depend on each other in any case. I talked about checking multiple concepts, and this is again very important. There is the idea of multiple asserts. When I see multiple asserts, I just want to make sure that they're on the same object. If they're on different objects, usually you're testing multiple things. But this also applies to mock objects. You should usually have no more than a single mock object per test. Now, mock object is a fake object, something that looks like the real one, that you assert against. You can have multiple stubs to break dependencies, like just make the logger mute or something like that. But if you're asserting that one of them got called, you should just assert on one of them, not assert on all of them. Because if you're asserting on one of them, you're actually saying that the end result is that an object somewhere has to be called. And if you have multiple objects that should be called, it's one of 2 options that's going on here. Either you should be separating it into multiple tests, or you're doing something called overspecification. Overspecification is when you're telling the test about internal work that goes on in the code, and you're coupling the behavior of the test to the behavior of the code. For example, I have a 5.5-year-old kid, and let's say that I send my kid out to get some pizza. So I say, here's some money, go down the street, go to that place, ask the salesman for a pizza margarita, extra large of course, and bring it back. And so my kid goes and comes back an hour later, you know, scratched and bruised because it was night and I forgot to give him a coat. But he comes back with the pizza. And instead of opening the pizza, I say, aha. Now I'm going to call the person at the pizza desk and say, hey, did a kid come by and ask you for margarita? Did he ask you with these specific words? No? And then I take a pizza and I throw it on the floor. The whole test is meaningless because the way things were done internally matter, and they don't. What we care about is the end result. Did I get a right pizza or not? I don't care how my kid actually got it. Okay? That's a very important thing. Overspecification is when you care too much about how things happened internally. And that makes your test unmaintainable. Because tomorrow, you're going to decide that some object is going to be called by some other feature 3 times instead of 2, what your test expects. And suddenly your test is going to say, but you told me it's only going to be called 2 times. I'm going to crash. But the feature the test is testing still works. The test is just trying to get your verification of what exactly goes on inside. So never, never, never try to fake and assert on everything that you fake. There used to be this notion that if you can create a mock out of it, you can also assert on it. Just because you can, you should. And I'm saying that just because you can means that you probably shouldn't, unless you don't have any other way to check an end result. Then, only then, one of these things is probably an end result. Maybe. Okay? So if you have mock objects in your tests, mock objects in tests should account for no more than maybe 5% of your tests. If you have mock objects in everywhere, your tests are cemented in concrete. You cannot change a line of code without fearing for your life that your tests will be yelling at you at the build server. And that's what we don't want, because you have 1,000 tests and you spend a long time to write them, and now you have to go and actually delete them, because who has time to change all that code to fit how the code works internally again? So if you want your test to actually last a long time, your test should care about the entry point and the end result, and everything in the middle should be as oblique and dark as possible. Sometimes you don't have any choice. Most of the times you do. So always make sure that what you're testing is either a return value or behavior change. And maybe sometimes, 5% of the time, you have to make sure that a third-party call was made, and then you would use a mock object. Yes? I'm not talking about black box testing, because that is acknowledging that I know the whole theory behind black box testing, etc. I'm just saying that if I think about it this way, it really, really helps me. Okay? Okay. How long do we have, by the way? We have 17 minutes, right? Okay. Readability. So readability is about structure, and I want to see the structure of the test very easily, but I also want to see where the test resides in my project. So for example, in this test, we don't even care what the test is. But I can see the structure, and I can see that the structure has multiple things that it's testing. That tells me that usually there should be multiple tests going on here. Other than that, there are some good things going on here. There is NaN, there's infinity, there are no magic numbers, there are no magic strings that I should relate to. Because as you can see, except 3 and 0.5 and all these weird numbers, there's nothing that I want to ask about. So maybe a couple of things that I don't like, but overall this test is kind of readable, but it's probably 3 tests in the same one that should be separated. Um, okay. So this is another example of a test. Let's see if you can figure it out. Nope, you can't read it here. That's not it. Okay, I have to work on that. How to zoom things on the Mac. I'm relatively new to this. Okay, should not transform table if transformer not found. So what I like about this test is that there is no magic string. There is something called inexistent transformer. Okay? Here. And that tells me an important thing is that the writer of this test took great care to make sure that the reader knew what's not important. All it says is and non-existent. They could have written foo, they could have written bar, they could have written a, but they explicitly want me to understand that this one doesn't exist. And this is an important factor in your tests, is that whenever you have the chance to express yourself, try to express if something is important or not important. If you need to input a number, and the number is not important, maybe use a variable that says any number. If the number is important, make sure that you use the lowest possible value of that number, so that no one is misunderstanding why it's important. For example, if you're testing with a two-digit number, you don't have to use 19, you can use 10. That's the smallest two-digit number. And then the next one, maybe you would use 11. Or if you want to use a three-digit number, use 100. Because our brain is designed to understand where things begin and to see patterns. If I can see the test where I say, aha, here I see 10, in this test I see 100, in this test I see 1,000, I can also understand the logical thinking behind the person who wrote this test. Should transform table with custom transformer. Now this is an example of the opposite. This test has a string called my transformer. Now as the reader of the test, as a serial killer, I have no idea what my transformer is. Is it a real class? Is it somewhere in the class itself? Is it in a separate file? Now I have to start looking for that. And it's a string, so it's even harder to find. It's not really a type name. So I have to start using the ID to start searching for things, and I don't want to do that. So if I do have to create some class, especially for tests, I would usually put that class right below or right above the tests that are using it in the same file, so that as the reader, I can just scroll up or down to understand where things are, how things are supposed to work. So I looked in this class, and I looked up and down, and there was nothing. So my transformer is actually a real class, but it's in a separate file. And I would not recommend that, if possible. Yes?
How I read it, the line that says use transformer, that's actually the my transformer created the table transformer.
Maybe. It could be.
Then it tested afterwards with the table transform.
Mm-hmm. So, what you were saying is that, as you understand it, is that when you say use transformer, my transformer is the name of something new that you create at runtime. But even if that is true, and it's probably true because you understand this class better than me, but even if that's true, then something in the name is wrong. Because I was looking in this test, and I didn't understand that. So I want you to be able to tell me that in words. How can you express in words or in code that this is the name of the new transformer? For example, you can say, not my transformer, or you can say newly created, or just-in-time created transformer. Okay, transformer I'm creating. Something in the name has to tell me that this has to do with it, because I don't know the API. And what I'm trying to also show is that usually you don't need to know the domain to find interesting problems in tests. You can do test reviews even if you've never seen the code, because some things are generic. Some problems have nothing to do with the domain, like having overspecification and multiple mock objects, etc. Some of them really do have to do with the domain. So you may not know why the test exists, but you should trust that there is a reason it does. If you know the domain, you probably can also tell if it's important or not. In terms of readability, I want to be able, for each project, to find the test it relates to, and for each hopefully unit or a method to find all the tests that relate to that method. So the structure is really important. Now, it doesn't matter if you have a convention where all the test projects start with the word test or they end with the word test. What's important is that you are consistent. As long as you're consistent, it's very easy to do. But if you have some of the test projects starting with tests and some of them ending with tests, and then you have a folder for tests, then everything is going to go crazy. So you should, as the first thing, is you should create a structure where everyone knows where to create new projects and create new classes that contain tests. This is another example of a test that actually I liked because it has a nice pattern. At the end, what I see is all the inputs, and I see all very small differences for each input, for each assert. Now, there is still a problem here. The problem is that, again, if one of these asserts fail, the others will never execute below it. So that's still a problem, and I should probably separate that into multiple tests. But what I do like is that when it does need to use specific inputs, it uses very simple inputs. I don't care what number it is as long as it applies to a specific category of numbers, of floats. So it uses the simplest input it could possibly input into here. And then I don't have to ask interesting questions like, why did you use that number? Well, it's like you use it in loops. In loops you have I and j. You don't ask what I and j is. It's just common to use just a name. It's just a convention. And here it's another convention that I would recommend, is to use inputs that you don't have to ask about them any questions. And while we're on the subject of inputs, a lot of tests will send the same inputs with multiple parameters if possible. And I would recommend that you always have different inputs for multiple parameters, especially if of the same type. Because sometimes the order of the parameters matters. So if you use parameters in the wrong order, your test should break. But if you're sending the same value, you don't know if the ordering of the parameters is important. Even if it's just one parameter and you have one test above the other and you're trying to prove a different point, use the next simplest point. Look at the bottom two. Use the next simplest point that proves what you're trying to prove. If I can send in just a different number to say that something wouldn't work, I will just use the next simple number after 1. And I can see a pattern there. So those were the three pillars: readability, maintainability, and trust. To achieve them, we have to learn to do test reviews. That is the one skill that I would recommend everyone to learn to do. It's a bit difficult because you have to learn to sit down with people and actually communicate instead of communicating with tools and machines. Most of us are already social creatures, but it's hard to just sit one-on-one and actually talk to someone about things that maybe you don't like. But that would be something to learn, something to grow out of. Because that is the true meaning of mentorship and teaching, is to sometimes work across things that need to be changed. And you have to learn how to sit with people and do that. So we have a few minutes. Now is a good time for questions. All the questions were here already? Of course, the guy with the white shirt, yes.
You said you don't use setup method in unit tests anymore. Would you say the same for teardown?
So you asked, you said I don't use setup methods. Do I also don't use teardown methods? So there is an interesting thing about teardown methods. You use setup methods usually to remove duplication. You use teardown methods usually to remove resources or shared resources that you have created. So I would say that if you have teardown methods, usually 95% of the time, you actually have an integration test on your hands. So that's a sign. It's not a bad thing, but usually you don't have to. The only time you need teardown methods is if you need to reset static singletons or something like that between tests. So usually I don't need it, but sometimes I reset static stuff. But most of the time I see teardown, I say, maybe there's an integration test here somewhere. What are your other questions? Yes.
How do you deal with interfaces and multiple implementations?
How do I deal with interfaces and multiple implementations in terms of how do I unit test that? Well, there's a pattern that I call, well, it's not a pattern that I created, but if you've ever heard of the pattern template method, it really applies in this case. So what happens is, let's say you have an iParser interface. Oh, sorry, it's .NET. Let's say you have a parser interface, and then you have a XML parser, you have CSV parser, whatever. What you end up with at the beginning is you have a set of tests for the XML parser, and then you create a new one, and you realize you need the same tests. So usually I end up with the base class that contains most of the tests for the original parser, and then I have derived classes for XML, for CSV. And the derived classes usually just create the instance of the thing you're testing, and they verify the output, because each one of them has different outputs. But the tests usually don't differ. That's one option. Another option to deal with inheritance is not to create base class methods, but to actually create abstract methods that have to be implemented, so that they're actually used as a checklist. And in that case, you want to create an XML parser, you inherit from base XML, base parser tests, and now you have to implement these 15 tests. So you'll never forget to implement them, because these are the behavior contract of that object. So you implement them the way you want, but you have to implement them. Okay? Other questions? Okay? Thank you very much, and I hope to see you at the panel later on today. And feel free to visit my site or just contact me by email. Thank you very much.